Good evening, guys. I'm Chris, and welcome back to this Wednesday's episode of Rift Amps. I've just taken the back off the basement cabinet, and it's got the, I think they're the Oxfords, aren't they? The 12 T6s. Very nice indeed. But I'm glad I did take the back off just to check. It's got the original crossover wiring up to here, but somebody's replaced the speaker jack wiring with some what looks like lamp cord, and they haven't done a very good job on the soldering up here. So we're going to redo that. I've actually got some stranded pushback wire just for this sort of job, so we'll use that. We'll take the opportunity to clean the socket as well, clean the contact. You can see the contact point there on the tang. Make sure that's all clean and nice and sorted. Redo that wiring there, then we can test the cab, make sure it's all good. But that is the inside of the basement cab. Okay, all done. So I had to strip back the original wiring just to get some clean strands there to redo a proper job, and I've replaced the brown lamp wire with some stranded 18 gauge cloth covered wire to match the original look. Very good indeed. I even tried to match the same twist, the amount of twists per inch. Almost got it. I used 1/2 meter of white and black each, because even though the socket obviously will be at this point, so you think you don't need that much, you need more, because when you pull the door off, or otherwise you won't be able to pull the door off basically. So you need to have that flexibility in there. So that's what I've done. About the same length as the original, or the stuff that was on there. But yeah, that's now done. So I can button this back up, all of the screws. There's so many of them. And we can finish getting the head sorted. Nearly done with that now, and then this job is done. Right, Q&A time. Got loads of questions and things this week, and I do apologise that this video is slightly later than normal. It's just taken me a long time to get everything ready and sorted, so I do apologise it's a couple of hours late, but I'm sure you'll forgive me. Anyway, Riley says, to the owner of the Fender amp, the Pro Reverb, the really clean one, please don't do any work, just put the thing away and use something else. It's a historic piece that will be worth a fortune, unmolested, in year to be. Well, Riley, as you watch the video, you would know that the amp is owned by its original owner. He plays it regularly. It is his amp. He loves it, and he's brought it in because it's got a few issues. And that amp has never been touched, apart from the on-off switch, which he repaired himself, since he bought it all the way back in 1980. So he's going to carry on playing it. He wants to make sure the thing is working so he can use it. But I understand where you're coming from. You know, but there already are places out there, you know, museums and things that have got mint examples which do not get played. So this one, it is his workhorse. He does enjoy it, and he wants to keep using it. Okay, back on the hook, Little Lenny. Now, I've been trying to hunt down the cause of the rustly game pot here. And as you rotate it, it makes a rustling noise. Two causes for that usually. First one is that the pot is dirty. Second cause is that there is a small amount of DC appearing on the wiper, and then when you rotate the pot, that causes that rustling noise. Okay. Where does the DC come from? It either comes from a leaky coupling cap, or it comes from backfeeding off the valve that the wiper is feeding. Usual cases, not all the time, but usual. I have replaced the valve before and after the game pot. No difference. Okay, not a problem. These things happen. But there's about 150 millivolts of DC appearing on the wiper, and it's not coming from before the pot, it's coming after. So I emailed Hook and asked for a schematic, because what I really don't want to have to do is to pull the PCB to work it all out. I emailed once, no response. Waited a couple of days, emailed again, no response. Waited a couple more days, emailed a third time, still no response. Okay, don't know why, just blanking me. So clearly something's going on there. I'm not going to guess as to what it could be, but for this moment in time, I'm going to assume it's, they just haven't seen the messages. But my customer needs this amp fixing. So if you're not going to provide me for schematic, or I can't get one, what's the next solution? Well, it's simple. I reverse engineer and draw my own schematic. Shouldn't be a problem. However, I have run into a problem in that I have been using my meter, buzzing out the first couple of stages, drawing it out, working out where things are connected, and pin 2 for the pot, which is this eyelet here, which has this jumper wire coming up to the pot itself. I have buzzed out every single eyelet on this board relative to that, and it doesn't connect anywhere. Now, obviously it does connect somewhere, but I can't find it. I've literally gone through every single eyelet on this board, and I cannot find where that connects, which means there must be a connection on the underside of the board that I simply can't find, or that you can't see and I can't get to. And in between that connection and another eyelet on the top of the board, there's another component, which is why there's no continuity. So what are the options? Well, option 1 is to wait until Hook finally get back to me with a schematic. How long is that going to be? I don't know. I've already tried 3 times. Do I send a 4th? Maybe. But what's the point? If they're not coming back to me after 3 times, then, why would they come back to me after a 4th? Second option is to remove all the pots, unsolder all of the wires, lift the board up and trace it myself. Now, in an amp like this, that's quite a lot of labour that the customer is going to have to pay for. Is that acceptable? Well, who knows? That's up to the customer, really. Do I think it's acceptable? No, I don't. It shouldn't be that difficult. It shouldn't be this tricky to fix what is essentially a very simple circuit with quite a confusing board layout. So I'm not happy this morning. I'm not impressed. Now, the quick and easy solution, and which I've already tested on the test bench, is to remove the jumper wire from the board, from that solder terminal, from that eyelet up to the pot, and simply install a blocking cap in its place. 47 nanofarad will suffice in this case. You install that into position, it blocks the DC, it allows all the frequencies to pass, and your issue's gone. That's the quick, simple and easy fix. It's going to be cheaper for the customer, it's going to work just as well, and we're going to get this amp up and running. So that's the decision I've decided to take. Some of you might not agree with that and say, no, you need to pull the board out properly. But my argument, again, is who's paying for that? Because I'm not paying for it. Hook won't pay for it. And I'm sure the customer doesn't want to pay for that when I can install a capacitor that costs a couple of pennies, a couple of quid, sorry, into its place, and the amp is fixed and sorted, right? So that's what I'm going to do. So as you can see, I've removed the wire. I'm just going to install this in its place, and then I'll put it on the test bench and show you just how quiet and how quickly that fixes that issue. I'm really annoyed that I can't trace this out, because then if I could, I'd then have a whole schematic that I could then keep on record and I would know. And if someone else couldn't get one for this amp and Hook didn't give them one, I would happily provide that. So that's what we're doing. That's where we're going. I'm going to install this cap and take it from there. Clark Blacker says, why don't you replace all those crappy plastic inputs with switchcraft jacks? They are junk. They are clearly the problem. No, you're completely wrong there. Cliff jacks are absolutely fine, and if you go back and watch the video, you'll hear me say that this is the first time that amp has been serviced or looked at in 20 years. And so you've got a clear case of just it needing a good service. The jacks themselves aren't the problem. It's just well overdue some TLC. I mean, at the end of the week when all your clothes are dirty, you don't throw them in the bin, you just clean them. That's what this amp needed, right? You don't need to replace the jacks. That's way overkill. That's not good diagnostics. That's not good amp teching. Just needs a good old clean. Okay, amp on the bench, mic up against the speaker, and I'll rotate the pot and you'll hear it doesn't make any noise. Excellent. Okay, and just a reminder, the other issue that this came in for was the customer said he thinks the reverb level changes when you flick from off to standby, or standby to play mode, and then you can flick it back and it returns back to normal. Well, it hasn't done that at all whilst it's been here. I've gone through and checked everything. I can't get it to play up. As far as I can tell, there's nothing wrong with the reverb circuit. So he understands that. He wonders if there's just some confusion there. You do hear a pop through the reverb when you flick the standby switch on and off, but that's not the issue he complained about. So we will leave this burning, and I've got a loop running through at the moment. That's why the sine wave looks weird. That's what a Ainsley loop looks like. And yeah, we'll call this one done. Channel member Project AMK says, love those Cornfords. Everything about them looks and sounds great. Do you know what? I'm a big fan of Cornford amps. They're always really well designed. They're really well built, to a very high standard. They're often, bulletproof and reliable. It's good quality components throughout. The only things that ever often needs changing on them is the valves themselves, and then just basic maintenance, cleaning and tightening and stuff like that. It's very rare, in my experience anyway, to see a Cornford goes down. And when I look inside them, or every time I look inside them, I should say, I always see some really interesting and novel approaches and ideas, how to build amps and how to approach certain tasks, and they're always really interesting from a designer's perspective. You say, that's a clever way of doing that. I hadn't thought of that. Or you can clearly see examples sometimes where he's worked around a known solution or a problem. And then also sometimes you see things where you see all the other techs and amp designers and whatnot worrying about stuff. Oh, this could happen, that could happen. You shouldn't do this, you shouldn't do that. But then the proof is in the pudding. Those things work great, and some parts of the circuit are the tried and tested classic ways of doing things, and they just work. So I think there's a lot of what if that goes on in this industry, and it's over the top. And when you see an amp like a Cornford, it answers a lot of questions. Quick update on Ed's custom build, the RK50, which is the RK100. We're doing a 50-watt version. Do you remember last time I got my calculations wrong for the bias supply and we had terrible crossover distortion? Well, that's all now fixed. The amp is up and running. It sounds really, really good. I'm massively impressed with it. I know what I want to do to tweak it slightly, but it ultimately, I think that should be Ed's decision. So I'm going to invite him down just for a tweaking session. But I'll show you the output sine wave. There it is. Very nice indeed. Very happy with that. I haven't quite got the foot switchable boost working right. I think I know why, but I just want to double check a few things on that. So yeah, but apart from that, we should be all good. It kind of works as an underboost, so it's you've got your normal mode, and then when you switch it on, it drops the gain level down, which is really cool. And I suppose you could wire the switch to work either way, whichever you prefer. So I'll talk to Ed about that, see which way he wants to do it. He did tell me I need to look up the notes, but yeah, apart from that, it's good. So once I've got those little bits and pieces done, Ed comes down and plays it. He gives me some, I think it should go this way, or actually let's adjust that, or whatever it is. Once we've got that done, then it's simply a case of confirming the way the head cabinet's going to look, the styling of it, the face plates and knobs, all that kind of stuff. We've got a rough idea, but I said to Ed I'll let him know when we get to that point where we need to make that decision, and then bung it all together and it's done. But it's really cool. Vex loop on the back, 8 and 16 ohm outputs on as well on the rear. That's about it. But we've got our input, we've got the boost socket there for the foot switch, gain, treble, middle, bass, master and presence, all working fine. It's come out really well. Yeah, really well indeed. So mega happy with this. On the, we had lots of questions and comments about the amp maker kit amp. So Mark N says, "Hey Chris, at 9 minutes and 10 seconds, you looked at the secondary and I thought I saw it was wired for 16 ohms. No? I know you took your first readings and looked at the wattage chart for 8 ohm. I'm probably wrong. It was probably 8 ohm secondary wired. You need to look at the rest of the video and you'll see when I did the original check over, the amp has got 2 output sockets, one 8 ohm and one 16. It's wired for both, and I was using the 8 ohm socket, and that's what we're measuring from."
Future Chris here. I've just been thinking about Mark's comment. I was trying to work out why he was confused, and it's actually the output transformer itself. The labelling is quite confusing. I'll just show you now. Yeah, so here we are. So both windings appear on both sides of the transformer. So there's nothing on, no wires on or terminals on that side. But on this side, you can see you've got terminals at the bottom and terminals at the top. The lower terminals are for your output taps, and as you can see, he's left the 4 ohm empty, so you've got 8 and 16 there. That's your common. But the upper row is for your primary, just your in and your out. But I can understand why you'd think it's the 0 and the 16 there, the way that's labelled. But yeah, just a bit of confusion there, but I wanted to correct that so nobody got confused.
The other thing I'm doing is just measuring up the control panel, the face plates for the Mad Amp. Remember, we're doing like a plexi style conversion on it. Never assume. That's what we're learning today. Obviously, it's a German kit. Germans in the EU, so they use metric, but it's a 10-inch chassis. It's exactly 10 inches. Which does also equate to 254 millimeters, so maybe it's that, but it's a 10-inch chassis. But the hole spacing for the controls appears to be neither. So I need to do more accurate measuring. I thought it was 1¼ inches spacing in between the two, but it's not. I'm going to have to pull the knobs off just in case a couple of them are off center, because I need to get this right and go from there. But yeah, so the other thing was he's asked me, obviously we need to keep the spacing for the IEC socket and the 8 and 16 ohm sockets on the back, but could we add some switching on the back, some voice switches maybe, see what we can come up with. So we'll think about that, but I need to know how much space I've got and other things. But yeah, that's what I'm doing, just writing these measurements down. Then I'll draw it up in Photoshop and see how it looks. Oh, actually, that reminds me. The only problem, remember, as it currently sits in the cabinet, is hanging from the ceiling, but he wants to convert it to sitting on the floor. Well, if it's that way up, you can see the centre line is not halfway up the chassis. It's maybe 2/3 of the way up. So we might not be able to do dials because of the overhang on the chassis cutout in the cabinet. So we might just have to do labels underneath, obviously this way up, but we might not be able to do dials and things, which might be a shame. But we'll do something cool with it anyway. But yeah, just measuring this up. Bimmer2047. On a separate note, actually, when I say these usernames, I don't know if the numbers are chosen by you or if it's just YouTube applying them. So apologies if that's not what your username actually is, and that's just what YouTube shows them to me as. It always seems weird that half of these have always got a random string of numbers on the end, but there you go. He says, I got a 65 Bandmaster that has red plated one of the 6L6s shortly after powering on. I shut it off and back on, and now it works fine. It has only done it twice. The tubes are 1 year old, and it was fully serviced at the time, including new electrolytics. Any idea where I should start looking? Yeah, absolutely. Take some voltage measurements. You've got to get inside there. You need to measure the anode, the screen, the control grid, and the cathode voltage. If you've got 1 ohm resistors there, in both conditions, the fault condition and the normal operating condition, and see what's going on there, because that will then give you a big clue. If one of those readings is vastly different in one condition to the other, then that gives you a good diagnostic direction to go in. So that's what I would be doing. The other thing you can do, of course, is swap the valves into each other's sockets, so swap them around. And then if the problem moves with the valve, then or the tube, it's the valve problem. If it stays with the socket, then you need to look at, focus on that socket. But that's kind of the basic. That's where I would start. Give yourself some data, and find yourself a diagnostic direction. Okay, so back on with the very, very clean Pro Reverb. Our first job is to do a cap job. So I've got some F&Ts to go in. So I'm going to pull these off. I'm going to measure the resistors that are in there and reinstall them properly. So we'll time lapse this for you guys so you can see me doing it. Yeah, enjoy. BMacQ says, "Hi Chris, I've seen you always checking the voltage on the mains, always seeking 240 volts plus or minus. EU has 230 volts. As you might already know, what would happen or what are the consequences if you get a UK Marshall, just for example, and plug it into any EU 230 volt socket?" Right, yeah, so we're strange in the UK. Historically, we're always 240 volt plus or minus a percentage. I think the maximum we can have is 252 volts out of the wall, right? Is it plus 8% minus 2%? I can't remember now. I'll look it up. And now the EU traditionally was 220 volts historically, right? Throughout. Now, what they did when we were a member of the EU, they harmonised everything and said the official voltage for the EU, including when the UK was in it, would be 230 volts plus or minus a tolerance, and that tolerance included the UK at 240 and most of Europe at 220. And so we ended up suddenly being all the same, all harmonised, without actually changing anything. It was just kind of a catch-all. That's where we'll set it, and that's where we'll go. But you do get these fluctuations, and let's answer your question first, right? If you plug an amp wired for 240 volt mains into a lower voltage supply, and when I say lower, slightly lower, 230 volt, the amp will run fine. It's quite capable of handling that, not a problem. In fact, it probably prefers a slightly lower voltage than a slightly higher voltage. The way a mains transformer or power transformer works is, let's say the high voltage winding is 350, so it's a 700 volt winding, and that's what it will put out if you put 240 volts in and it's wired for 240. You put 230 in, but it's a 240 volt winding, you're going to get lower voltage on that side. Generally cooler for the amp, not a problem, the amp will be fine. It's when you go the other way, let's say the amp was wired for 230 volts or even 220, you plug it into the UK socket, which might have 240 volt, but it could be all the way up at 250. Suddenly you're getting a massive overvoltage inside, and the amp might not tolerate that. It might struggle. Some things are built more robustly than others, and And so the old rule was, and this was on gear that had a mains voltage selector, so you could select the mains voltage, was that you measured whatever the wall voltage was and you selected the one that was higher than that. So, for example, today my wall voltage this morning was 242 volts. Now, if the amp had a 250 volt selector on it, that's what I would choose. If it didn't, I'd have to go with 240. It's my only option, but I wouldn't go 230 or 220. You understand how that works? So it's more dangerous when it's a higher voltage supply than what the amp is set for, but generally you're safe if the amp is set for a higher voltage than it's actually receiving, as long as it's in the ballpark, right? I'm not talking about 120 volts into a 240 amp, and certainly don't put 240 volts into a 120 volt amp. Things will go bang. Okay, Pro Reverb on the bench. Recap is done, well, at least in the high voltage roll. I haven't done the electrolytics on the board just yet, but it's now safe for me to fire this thing up and get some baseline measurements, do all that sort of thing. So at idle, this thing pulls 97 watts out of the wall. I'm driving the vibrato channel mid on full, treble and bass on 0 or 1 as you call it on these. Master volume up full. We'll just advance the gain, and you can see you're starting to get some changes to that sine wave. So we'll just back it down just to the point there, about 14.5 volts I would say. 14.5 into 4 ohms, sorry, is 52 watts. And these famously should do 70 watts clean all day long. That's the whole point of them, right? So we're a little bit down on power. We need to investigate why. But yeah, so I'm going to go through, I'm going to take all the voltage measurements that I need, do a little bit of scoping out, seeing what's going on. But yeah, it is a little bit down on power. Causes for that, well, numerous things it could be. Obvious things, worn output valves. Phase inverter isn't providing enough voltage swing to drive the output valves hard enough to achieve the power it wants. We could have a low voltage inside. We could have all sorts of things going on. So we're not going to assume, and we're not going to, shotgun parts that we don't need to. We're going to diagnose it properly and see if we can work out, why this amp is only doing 50 watts when it should be doing 70. Back on the Ampmaker SE5A, Johnny Moondog says, was also wondering what mods you would do if it was your amp. I love the Luke demos too, the most useful display of an amp's range I've heard. So start with the first part of your question, what mods would I do? I think I pretty much explained that in the video. I would definitely add a third gain stage, and I would, again, if the power transformer can handle it, I would do split output valve, so a 6v6 and an EL84 with a pot to send the signal to one or the other or both and anywhere in between. That's a really cool thing to do. You get some really interesting sounds. What else would I do to that amp? Personally, I would probably revoice it slightly. I wasn't, as you heard in the video, I wasn't a fan of the top end, even though the treble control was powerful enough to take it out. The character of the top end wasn't quite what I like in an amp if it was mine. But that's the problem with this game. When you're designing an amp and building an amp, you're not doing it for me, I'm doing it for what the customer wants. So, sometimes those two things can be different. Is there anything else I would do? Probably not, because I do like the simple amps. I mean, if you look at it, it's a EL84 champ with a treble middle bass tone stack. That's how simple it is. But less is more in those things often. Adding all the switching functions might be fun, but you end up messing with these things and switching things more than you do actually playing the amp, which I think should always take priority. And finally, Planet Caravan, our longest serving channel member, simply says, nice calculator. Yes, I'm very pleased with them, although they've got they beep when you use them, and they've got a button to turn off the beep, but it doesn't remember that, so you have to turn off the beep every time, because I can't stand devices that beep every time you press a button. So, but apart from that, it is solar powered, very nice. And they work great. He actually got me 2 of them, which is very kind. So I have no excuses not to use them, and I could finally retire the iPad and its cracked screen. Well, that's it then, guys. Thank you very much for watching once again. Big shout out to Dan Hodges, who's now been a channel member for 6 months, joining 3 other guys who have now hit that threshold. So to all of you, thank you very much indeed. As always, please give this video a thumbs up, all your comments and questions down below. Subscribe, hit the notification bell. If you are feeling generous, why not join the channel? And I will catch you all at the next one.